everyone, welcome back. In this lecture we're gonna be quickly going through basic programming or basic theme of Matlab and Octave coding. Okay, so let's say if you wanna quickly get your hands dirty on with Matlab or Octave coding, you can watch this quick tutorial and you should be able to do that. So what it is, the Matlab and Octave, okay, you may think of, it's the similar thing, except you have to pay license cost for Matlab, and Octave you can download from GNU website. It's an open source software. So idea of Octave project was to do the same thing what Matlab is doing, okay, and to help academia or students who cannot buy the expensive license of Matlab. However, there are many subtle differences. First of all, as you know already, that Matlab is proprietary and Octave is open source. So of course there might be some kind of installation and back and forth support. You might have to look for Octave, but recently the guys have done a very wonderful job that you can just download Octave and get the programming as quickly as you can do with the Matlab. However, Matlab is there since many years, and these guys, Matlab guys, have so many inbuilt libraries, functions, different toolboxes. So if you're going to use Octave, you might have to write your own functions or libraries, but nevertheless, it's the same thing. Like in Matlab, it treats everything as a matrix. Same thing in the Octave. Okay, so whatever you download, either you work with the Octave or either you work with the Matlab, your program should work. Okay. However, some syntax of Octave may not be compatible with Matlab, but that's sort of it's not. It's like if you go into very detailed or some special functions you want to use in Octave, which may not work in Matlab, but Matlab syntax will work in Octave in most of the cases. Matrix is the key for these software packages, or say programming in Matlab or in Octave. So think about, let's say you define a variable, say a equal to 10. What does it mean? In a simple way, you can think of it's a matrix, just one element in the matrix. So does that make sense, that this a equal to 10 variable, scalar variable, and you can think of a vector variable, just one element in the matrix. So that's the key idea. Always remember, you have to think in terms of matrices. Then you can write an efficient program, and or how do I say, in other words, you can make use of these software packages to maximum. Okay, if you think in terms of regular programming languages, let's say C, C++, you have to write a loop. Okay, loop I equal to 1 to 10. Okay, but what does it mean by the loop? In other words, it's you may convert that loop into a vector operation, okay? And then a Matlab or Octave can solve it very efficiently. Matlab supports many built-in libraries, many toolboxes for solving varieties of scientific problems. So you may think of in that way, that if you're gonna be using extensively for your research, you can go ahead and ask with your department advisor or university to give you a Matlab license, buy a Matlab license for you. But if you don't want to spend money, or you do not have money, then just download Octave and work with it. So any fundamental concept will teach about variables. Okay, and let's say in C, C++ programming languages, you have integer, floating point, or different data types. Matlab made it simpler. How? That every variable you can define, it will automatically take it as a floating point or integer. You don't have to worry about it. You just have to worry about that the variables names are case sensitive. Okay, and it has to start from a letter. Case sensitive starts from a letter and cannot have same name as a keyword name. That's just few basic things for defining a variable. For example, A6 is a valid name. 5A is not a valid name. Value is a valid name. But AND is not a valid name because AND is a keyword in Matlab. And there are many other similar things or like many other keywords you may find on Matlab website, which you cannot have a name, but this is in general principle. Okay. And there are special variables in Matlab. Say pi, value of a pi, ANS means answer, what was the last variable value. EPS, the smallest increment in floating point terms, what Matlab uses. I and j, these are for complex numbers. Okay, for example, a equal to 2 plus 4i, so 2 becomes real part. Okay, and 4i becomes imaginary, so means 4 is a imaginary part of this complex number. Now this vector has a 2 elements. Okay, and both are complex numbers. Okay, and there are other special variables, say infinity, not a number, nan, computer version, real min, real max, what is the minimum real number it can represent, same way real max, then same way what is the minimum integer it can represent, int min, int max, and so on. So you can check on MathWorks website for many more special variables. Okay, now let's talk about operators, basic operators, arithmetic operators, addition, subtraction, multiplication, division. These are as in any other programming language. This is for taking the power cap. So it's like you want to have say 2 to the power 2 is equal to 4. That's it. Okay, power operator. And then relational operators, equal to, greater than or equal to, not than or equal to. Notice here that in C language you typically use exclamation mark and equal to. So this is in C++. You use here, you use tilde sign and then equal to. Okay, less than equal to, greater than. All right. There are logical operators and, or, not. For example, let's say you want to do a AND of two matrices A and B, or you can also do A and B. So the difference is simply in the bitwise. So this ampersand sign is a bitwise and is a logical AND. Okay. Same way, or and not. And then there are some set operations which you can find detailed information, but in simple sense, that append some value you want to append to a set, cardinality of a set, you want to check whether some element set contains certain element or not, that is contains, in belongs to a set, intersection of two sets, minus A minus B. Say for example, let's say you have A set, so B, A minus B, okay, union A union B. These are set operations, and so on. Universe, JIP combining two lists together, that's a JIP operation. Okay. Now let's talk about matrices. So all variables are considered as matrix or matrices. Okay. So as we discussed earlier, A equal to 10 means it's a matrix having just only one element 10. Or if you have A written in this way, 10, 3, 9, what does it mean? That it's a column matrix just having a one column and 3 rows, 10, 3, minus 9. So remember here that we have put semicolon, okay, semicolon. So that makes that 10 make it a column. So before 10, whatever it is, one column, second column, third column. Sorry, so 10 is one row. So semicolon separates a row. Then 3 starts next row, minus 9 starts next row. Okay. Now if we have just a comma, what does it mean? It means that we have just 3 columns, 2, 3, minus 5. So remember, semicolon means row, column, just a comma means column, create a column. Easy? Okay, good. Now let's talk about a little more complex matrix. Let's say we are writing it A 1, 2, 3 and then semicolon. Okay. So what does it mean? That okay, 1, 2, 3 make it a row, because we have put, you know, semicolon is separating the rows, and within that row we have 1, 2, 3 means 3 columns. First column 1, second column 2, third column 3. Same way, this will become a second row and 4 will become the first element in the second row, and so on. So how we can say, visualize it? A equal to, it's a 3 by 3 matrix, or say 1, 2, 3. So this 1, 2, 3 becomes the first row before the semicolon. Same way, 4, 5, 6 becomes the second row. Okay. And if you want to put a table, or let's say you want to put rows and columns and you want to separate it out, so as you can see here, if we number it, then we find there are 3 rows. Okay. And same way, if we number the columns, we find there are 3 columns. Okay. And let's say if we want to extract, okay, let's say value 6, or we want to know what is stored at this location. So if you see here, 6, it's in the second row and it's in this third column. So how we can know that number, what is stored at the second row and third column? If we say A second row and third column, A 2, 3 equal to 6. A little more complex, let's say if we want to have fetch out all elements in the second row, means second comma colon. If we type it that way, we get the full row. All right, very simple. Now let's talk about simple extensions of matrices. Let's say you defined a matrix A as 10 and 11. Okay. Only one row and 2 columns, 10 and 11. And you want to extend that matrix. So what you want, if you want to type 2, 3, means in the second row, third column, the element value is 0.1. Good, it will store, and the resultant matrix will become 10, 11, 0, 0, 0, 0.1. So what it is, that all other entries it has filled with the 0. Another example, let's say we have a 2, 3, 4, 5 2 by 2 matrix, and if we want to extend or if we want to define a new matrix as in this format, okay? So we want to copy, at the same time we want to multiply with some scalar to this A matrix. So A, 2 multiplied by A, and then in the next row 3 multiplied by A and 4 multiplied by A. So how the Matlab gonna do that? It will copy, because you have put A, so it will copy the whole matrix 2, 3, 4, 5. Good. And then 2 multiplied by A, so it will multiply each element of A with the 2, that is 4. 3 multiplied by 2, 6. 4 multiplied by 2, 8, and 10. That becomes second column, you can say. Or let's say now you have 1, 2, 3, 4 columns, okay, and 2 rows. Now at the next row or column is basically semicolon is separating the row. So 3 multiplied by A. So what it is, multiply every element of A by 3. So 3 multiplied by 2 is 6. 3 multiplied by 3 is 9. Okay, and then 3 multiplied by 4 is 12. 3 multiplied by 5 is 15. So that becomes the next entry. And in the same way, the other entry, 4 multiplied by each element of A, you multiplied by 4. So 4 multiplied by 2, 8, 4 multiplied by 3, 12, 4 multiplied by 4, 16, 4 multiplied by 5, 20. So how did it do? See, copy and then multiply. So how many rows and column it became? 1, 2, 3, 4 columns and 1, 2, 3, 4 rows. Okay. So initially we had this matrix 2 by 2. And after copying and multiplication, we had this matrix having our row 4 by 4. Good, easy. Now let's talk about addition. You have been given a matrix A and you want to perform an operation B equal to A plus 1. The resultant matrix, what it is, that is going to add 1 to every element of A. So 10 plus 1, 11, 11 plus 1, 12, 12 plus 1, 13, 13 plus 1, 14. Good. Now if you want to do A plus B and store in a C matrix, you can do that way. C equal to A plus B, and that's a matrix addition. You get the result here. Okay. Same way multiplication. Say you want to have D equal to B multiplied by C. So you get the result of this matrix multiplication, or you can say think of that what you will do manually to multiply the matrix B with the C. So 11 multiplied by 21 plus 12 multiplied by 25 becomes the first row and first column of your D matrix. And same way, this multiplied by this. So this multiplied by this. Now that becomes that. Okay. Now again, to make it the second column, this multiplied by this becomes the second column. Okay, so 11 multiplied by 23 plus 12 multiplied by 27. Now to make it a second row, this is our second row. This multiplied by this becomes the second row. 13 multiplied by 21 plus 14 multiplied by 25. Okay, and again for the second row, second column, this multiplied by 23, 27 becomes your last element. Good. So that was a simple matrix multiplication example. Now there are talk about some basic useful functions that you might need to use. Different ways you may use simple functions. Zeros to make an array of all zeros, ones to make an array of all ones, I to make an identity matrix, random number to generate a matrix of random numbers. So remember, in computer language we call it random number, but ideally it is a pseudo random number. Means that those are not really 100% real numbers. The random numbers, they can be generated in a loop. So it will give you a pseudo random number. Diagonal of a matrix, DIAG, size, what is the dimension of the matrix, length, what is the length of a vector, determinant of a matrix by DET, inverse, what is the inverse of a matrix, eigenvalues of a matrix is you can get by EIG function, rank, what is the matrix rank, find if you want to find some L, or if you want to perform a search in a matrix. Okay, there are more useful functions. Say ABS finds absolute value of all elements in a matrix. Signum function, sine, cos, exponential, sine, cos, or tan, cot, or trigonometric exponential functions, log, natural logarithm, log, log 10, log and base 10, ceiling and floor values, that is round values, towards the higher side, that is ceil, and the lowest side, that is floor, round to nearest integer, rounding a value to nearest integer, and real and imaginary parts of a complex number, sorting in ascending order, that is sort function, min max function, finding maximum and minimum values. To find the standard deviation and variance is STD, VR. These functions STD, VR may be very useful when you want to develop some financial algorithm, or you want to write some code for, say, financial option pricing, for example. You might use these inbuilt functions, mean, median, again, statistical functions. All right. Now, plotting is an integral part why Matlab became so popular. Plotting is one important aspect, and it's simple in Matlab. A very simple example, let's discuss. In this example, you have a variable x. Line space is nothing but doing that, dividing the whole 1000 points in equal spaces of 2 multiplied by pi, that value. Okay. And then y is nothing but calculating the sign on each point of matrix x. Then z value is calculating cosine or cos on each point of matrix x. Okay. And then hold on is nothing but that whatever you are plotting on the graph, that will stays on. If you want to have every time you execute the plot command, it will replace the existing graph. Not to replace existing graph, we are using hold on. Okay. And then you are plotting for, first time the y values, and second plot command you are executing and plotting the z values or z values. Okay. And then finally you are putting some labels, x label, y label, title, legend, and if you do grid on, it will make a grid on. Okay. Now let's talk about some flow control mechanisms. So these are like in any other programming languages. You have conditional statements, you have looping statements. So in Matlab, we basically here for this lecture concentrate on these 4 flow control statements. If executes the conditional statement, say if I equal to j, then value of the aij element is 34. Else if I is greater than j, then value of the element ij, I is the row, j is the column, becomes 10, and so on. So that's the example of if statement. And then in the end, this is the end keyword, that now your if statement has ended here. Okay. Switch statement, it is a switch case statement. Like in other programming languages, you have a switch statement for selecting different cases. Same way here, but based on the value of the I, if I is equal to j, you select that case and make the value of aij is 34. Okay, so it's a similar to if statement. And when you don't have any of the conditions satisfying any of the case, by default or otherwise, aij make it a 0. Okay. So in C++ you use the default, here you use otherwise. Good. The while loop. Okay. While some condition is true, I keep on executing the loop. So that's what the while loop is. So in this example, while value of the j is less than 10, then execute these lines. Ij equal to 8 multiplied by j equal to j plus 1, and end. Good. And for loop. For loop is similar to while loop. While loop is it's just a way of how do you write for j equal to 1 to 10. Execute this line for 1 to 10. Good. So remember, in while loop, you have to increment the value of the j looping variable. Here in for loop, it is automatically getting incremented. So for j equal to 1 to 10, and end. Good. Nothing complex. Now there are some useful functions of input output, which is many times you might have to save the data and read back the data. Okay, you might write the whole information or different variables to an Excel file and read back from the Excel file. So let's talk about the load. So load is basically loading the value from a file. So how does it go? That the keyword load and then the file name, whatever is the name of the file, it will load everything from that file name. If you just want to load the value of the variable x from the file name, you execute load file name x. If you want to load all the variable which starts from x in a file name, okay, then you execute load file name x star. Good. Now let's talk about save. It's very similar to load. So if you want to save all variables in a file, you execute save file name. If you want to save only variable x and y, then save file name x and y. File name is nothing but your choosing file name. If you want to specify the path of the file, you can do that. It will save the file at that particular path. Good. Now XLS read. It is a reading from the Excel file, XLS read. Okay, x equal to XLS read and the file name. Now here the file name, if your file is existing in the Matlab path, you just write file name. If the file doesn't exist at the Matlab path, then you have to give in columns the full file path, and then it will read the file from that location. Okay, and put every information in the matrix X. Or you want to have, say, two columns, you can do that, x1, x2, whole information reading from the file, okay, will be stored in x1, x2. So you may have same structure in the Excel file for the columns. Okay. XLS write is simple, that whatever value is here in X, you want to write that value to the Excel file. Good. Now let's talk about some key points for an efficient code in Matlab and Octave. Okay. First of all, always think in terms of matrices. Good. Then avoid using loops as far as possible. That's another key point. The loops in many cases can be converted to matrices. Use the vectorization techniques. What does it mean? That you revise your code which involves the loop and convert it to matrix and vector operations. Always pre-allocate arrays. Try to always use Matlab internal functions because those are most optimized inbuilt functions which Matlab has provided. Avoid the use of global variables as far as possible. They are there, global variables are there for certain purpose, but don't use them often. Okay, write independent functions, and it's like in C language you write independent functions. Create new variables if the data type changes. For example, if A you have been using for integers, okay, say 11, and at some point in time you wanna use some floating point numbers or floating point number, then use a different variable for floating point. So whenever data type changes, use different variable. Okay, and avoid overloading the built-in functions. So what does it mean? That the overloading concept coming from the C++. If you're not familiar with the overloading concept, you may watch my lecture on C++ programming. Or in simple terms, overloading is nothing but you keep the same name as a built-in MATLAB function. So don't do that. Avoid that. So for that, you might have to look in the different functions what MATLAB has, but you can often get that on the MATLAB command prompt. If you use inbuilt MATLAB functions, it will change the color, the syntax color will change. These are some in general basic tidbits for writing an efficient code in MATLAB. Okay. Now let's talk about an example. So in this example, we are using a for loop. Okay. Looping variable for loop goes from 0 to 10 in an increment of 0.01. Okay. And we are calculating h. Okay. And at each point, okay, 10 points, each point of h, we are calculating the value of the cos. Okay. Cos k, cosine k. Good. So think about how we can represent, or we can change this for loop to matrix. So think about these 10 values. We can think of h is a matrix of 10 values. So this h in the end will become a matrix of 10 values. Okay. So does it give some idea? So after vectorization, just think of h is cos k. Very simple. We just don't have to write this whole for loop. MATLAB will internally will do that. So this h matrix will have the cosine, okay, for each 10 different points. Take another example. Okay, in this example, we have this complex equation. Okay, so at each point k, we want to calculate this expression and store at a k location in matrix H. And here what we are doing, say 1 by 12 is scalar, pi is scalar, A is a vector and B is a vector or a matrix. So at each element, okay, or each element of the A matrix, we are taking the power of by 2. Okay? And then whole thing we are multiplying by the element k of the matrix B. And we have this for loop. So think about that A is a matrix, B is a matrix of the same length, and H would be a matrix of same length, because every matrix is dependent on K. So K 1 to 1000. So each matrix A, B, and H would have 1000 values. Good. So how we can convert it in a matrix form? It's very simple. Say we have taken off the for loop. So it's a matrix essentially. So if we multiply each element of a matrix A, sorry, this is a each element or element wise operation, and cap is nothing but the power operation. So if we take element wise power of each element of A and then multiply that each element of this resultant matrix by each element of B, we get the H after multiplying this scalar. So we kind of converted this for loop to a simple matrix equation. We're done. So that would be a efficient code, okay, rather than executing the for loop. Good. Let's talk about Matlab programming or Octave programming in real mode. I have downloaded Octave open source package and installed GNU-plot with it for plotting. And let's say basic functions or basic things what we discussed in the lecture, how we can implement in Octave or Matlab. Okay. So let's say A equal to 10. So what does it mean? A matrix A having just one value 10. If we say A equal to say 10, 11, okay, that will have one row in the matrix having two columns. If we want to write it A equal to 10, 11, then 20, 21, that will have two rows and two columns. The semicolon is separating the rows. Good. Now, one more thing here. If you do not type semicolon at the end, it will print on the prompt. But if you type semicolon, it will not print on the prompt. And if you do ANS or say type A, it's here. Another thing, I did not discuss function in this lecture, but function is nothing but a very simple concept like in other programming languages. If you want to write a function, so you can do this way, function, function is the keyword, and here the return variable, what function will return, okay, and you may have many return variables. Then my function and whatever is the variable of the function, let's say x, okay. And now if I want to say return variable of the function is equal to x plus 3, okay, it's a very simple function and end. Good. Now if I want to execute that function, say C is equal to my fun 2, okay. So 2 plus 3 is 5, is equal to 5. Now if I want to say D is equal to my fun 3, so D is equal to 6. See, 3 plus 3 is 6. So and so on. So what function is simply that you don't have to type x plus 3 again and again, you can use just simply my function. So you can combine, say for example, combine multiple statements in one function and club it together. For example, you can write a complex function say t is equal to my function 2, and it takes a value x, and you can say complex equation you can write for equal to x power 2 plus 3 multiplied by x plus 5. Okay, so you don't have to type this whole expression and again. You can just simply execute. If say e is equal to my fun 2. Okay, so e will have 15 value. You can check that 2 multiplied by 2 is 4 plus 3 multiplied by 2 6, 12, and then plus 5. Okay, so 2 multiplied by 2 is 4, and 3 multiplied by 2 is 6, 6 plus 4 is 10, plus 5 15. And let's say if you have 3 23, you can have say 5 and store in a different variable 45. So see the functions, how easy they are. Good. We discussed about addition, subtraction. So let's say we have a matrix given 10, 11, 20, 21. If we say b equal to a plus 1. Good. Now if we say c equal to a plus b. Good. Now if we say d is equal to b multiplied by c. See how easy it is. Now let's discuss about plotting. Okay, so let's define x is equal to equally spaced points between 0, 2 multiplied by pi, 100. Okay, y equal to sine x, z equal to, well, let's first plot it. Okay, plot x, y, and which color? Let's say red color. Okay, so we got a plot. Good. How beautiful plot is that? Okay, now we see z equal to cos x. Okay, now if we execute plot x, z, and green, okay, color green, G for green color. So see the notice here, the previous plot is gone and it has replaced by a new plot of the z, which is cos x. Good. Now if we want to retain this plot on the same graph, we have to use hold on. Okay, and then if we type if we plot y again on this plot with a different color or red color, say, this plot will stay. So you can basically overlap different plots on the same graph. Okay, now if you want to put a label x, L-A-B, We can put a label on the axis by using X label command. Professor X. Okay. See, you see the label here, LeProfesseur X. You can have any label of what you want to have. Similarly, to label the y-axis, we can do in this way. Y label is LeProfesseur Y. Okay. And if we want to have a title of the graph, we can have a title, LeProfesseur plot. So as you can see here, that it's very simple. These commands are simple, not too complicated. Good. So thank you very much, guys, for listening me. The objective of this lecture was to give a quick overview over Matlab and Octave, a few basic tricks. If you have questions or if you want to learn more, feel free to leave me a comment. I will try to answer all your queries up to my limited knowledge, what I can do. Please feel free to write your comments or send me an email for your questions, queries, or if you want to learn other concepts. And thank you once again for liking, subscribing, and Google Plusing LeProfesseur. Those who have not subscribed, please do subscribe. That way it helps to give you notification as soon as new lecture is available.